Hi everyone, I'm Ali, and I've come from London in the United Kingdom to talk to you today about web application security. I've been a web developer for about 8.5 years, and in that time, more or less every code base I've worked on, I've found at least one pretty serious security vulnerability in there. Okay. In today's talk, I'm going to be speaking about a few of the insights I've picked up working with developers to make their software more secure over the past couple of years. I'm going to talk to you about some case studies of what I think are the most prevalent vulnerabilities I see in Rails applications. And I'm going to finish by giving you a few recommendations of what I think you should be able to do to reduce the impact of vulnerabilities in your code. Okay? I'd like to start by saying that you're all developers, you're my people, and I love you. Okay? Everything in this talk comes from a place of wanting good things for you, for your users, and for the people who employ you. So I'm going to say maybe a couple of angry things, but there's no offense intended. It's just the way, things that I've discovered and things that I think are going to help you make more secure software. Okay? First, the bad news. We suck at security. We suck profoundly at security. In fact, we suck so bad at security that there is a whole other industry, and all they do is find the ways we suck at security and document them. Okay? Right? And it's a thriving industry, right? Like, we produce enough security vulnerabilities to feed and clothe their children, right? Like, and this is a very big industry, and that's all they do, right? That's bad. That's terrible, okay? And based on my findings, based on all of the thinking and research I've done, I've come to the conclusion that all software has security vulnerabilities in it. It is the natural state of software to have security vulnerabilities in it. And you can deny that fact if you want. In fact, I think most developers don't really want to believe this, right? Because it means a lot of work for us. But you don't need to believe it for it to be true, right? Twitter and Hacker News are going to remind you that there are new vulnerabilities in software that you run in production every couple of months. It's going to remind you that there are companies like eBay who are being breached right now. And that's going to keep happening, whether or not you believe this is true. So where does that leave you as a developer, as somebody who builds software that you, I presume, want to be safe for your users, for your company, and yourself? Well, to start with, you can accept that this fact is true, and then think about how you want to respond to publicly reported vulnerabilities in your code, right, in libraries that you use. You can think about how to reduce the number of vulnerabilities in code that you write. And finally, you can think about what you're going to do to mitigate the effects of vulnerabilities in your code. So you know they're there, but even though you are breached, you can recover from that swiftly and safely in a way that doesn't cause a lot of damage or impact to your users. Okay? The next insight I want to share with you is that, and this was really unintuitive for me, like it took me a long time to come to this conclusion, that there's no connection between developer skill and ability to ship secure software, right? I've met developers and worked with developers who are smarter than me, like are better developers than me, that by any metric you could possibly measure by, the quality of the code, the way they deal with other people, all of those things, they are better than me, right? But I still am able to find trivial vulnerabilities in their code, okay? I've also met developers who are just starting out in their careers, just like a year or a year and a half in, and the code's really messy, like it's not indented right, and the variable names are terrible, and it's just horrible to work with, right? But you're mentoring them, so you want to be nice, so you don't say all those things, right? So I've looked at their code, and you can tell, like I've asked them, like, have you thought about the security implications of this? Because I'm the security guy, right? And I look at their thought process, and I look at the code, and it's horrible code, but it does the job for the security, right? There's no obvious vulnerabilities in it. So what that did for me is it decoupled the idea that really, really good developers write secure code, and really terrible developers write insecure code, right? Those things aren't related. So what does this mean for us? It means that, firstly, the good news, and this is true for all of us, we all write insecure code, so do I. we shouldn't beat ourselves up too much about it, right? It's just a natural part of building software. Code is insecure. That's okay. But the other side of that is Dunning-Kruger, right? It's overestimating your ability at security. If any developer says to me that this bit of software is secure, the question I have for you is, what have you broken lately? What evidence is there that your opinion on that matter means anything? And if you don't have a good answer to that, then sorry, but I'm not going to pay much attention to that opinion, right? And even me, like I'm supposed to be the security expert in the Ruby community now. The highest appraisal I can give of any bit of software is to say that I couldn't find a way to break it. I can't say anything further than that, right? And that's entirely subjective and dependent on my skill level, okay? This fact here, this is kind of like my central thesis about security, right? Of if there was one sort of fact I could boil down pretty much everything I have to say about security and building secure software, it would be this. It is that in order to defend against attacks, you need to know how they work, right? And nothing will substitute for this. I've given this talk, or versions of this talk, to many, many different developers at different companies, at different meetups, and all the rest of it, and I know the questions I'm going to get. I'm going to get questions like, okay, so what could the libraries like Rails do to make our code more secure? What could we use as a static analysis tool to make our code more secure? What could we do in terms of like setting HTTP headers to make our code more secure? That stuff's all great, and that stuff's all important, but it does not even come close to how important this is, right? You, as a developer, personally understanding how vulnerabilities work is the most important thing. Rails can have whatever API they like for whitelisting parameters or whatever, right? If you, as a developer, don't understand the details of how to attack that particular vulnerability, then you have no chance of defending against it. And I'll go through some examples that kind of highlight this point in a bit more detail. Okay. So next, I want to talk about some case studies. There's nothing new that I'm going to show you. I'm guessing most of this will be old news for you. All of the stories I'm going to talk about are entirely fictional. So any resemblance to real-life companies is a coincidence, I promise. This one will be kind of, okay, this is the one. So about 2.5 years ago, I was working on a project with, and basically the organization was spending something in the region of, I think, if my math is right, about $3 million on effectively building a content-managed website. Right? This happens, like it was a shock to me as well. The consultancy they brought in to do this is huge. If I said their name out loud, you'd all know who they were. They write the books on like all the best practices. They make them up, right? I was on this project, and I was thinking to myself, yes, I'm going to do like all the good stuff, like the continuous integration, and like I saw the test suite, and I was like, this is amazing. Like unicorns flew out of the screen when I ran it, and it was brilliant, right? It was absolutely wonderful to be working with a whole bunch of really smart developers who seemed like they knew what they were doing, right? And I think they did, right, based on what I said before. And on something like day 2 or day 3, I was just reading through the code, trying to get an understanding of how the system worked. And I thought I'd spotted a pretty obvious vulnerability, and I wasn't sure. So I took some time, I made sure I researched it, I figured out exactly what context that code was running in. And it turns out that the user's update action was completely open to the internet, right? It was just no controls around it whatsoever. Okay. That meant that all you need is curl and the right parameters to send to it, and you could modify any record in the users table in this application, right? $3 million, right? And so you'd think they'd catch that one. And this was still at a point where I thought that, really good developers don't write insecure code, which I don't think anymore, right? They didn't spot this vulnerability. And when I brought it up, like the excuse was, well, that's just because Rails doesn't do anything for you by default. It's like, which is a bit of a bullshit excuse, right? Like you're responsible for the code you have in production no matter what Rails does for you, right? So no access control, no checking as to whether this user is allowed to do what they should be, what they're trying to do right now, right? It's one that I see in one Rails application after another. It's a pretty big deal, okay? Secondly, mass assignment. You've probably heard of mass assignment before. I think like the canonical example of mass assignment was more than a few years ago, a 19-year-old Russian by the name of Igor Homakov found a way to commit to the official Rails repo on GitHub, to push to it, as DHH. Okay? And the way he did this was from what at the time I thought was very, very clever. Right? What he had in GitHub, you have a form that allows you to create and also to update a public key, right, for which you have the corresponding SSH private key. Right? And what he did with that is realizing or guessing that there was no whitelisting of parameters on that form, so you can modify any field in the record that presumably GitHub has in the database somewhere on that record, right? He thought, okay, well, this public key record must be associated to me as a user, and it must have a user ID because I can have many public keys. So all he did was, right, well, I'm going to try submitting a different user ID. He flipped the user ID to that of DHH, and by doing that, GitHub allowed that to go through and save that record to the database. He was then able to authenticate as DHH, right? Really sneaky way of using that vulnerability. And this one actually turns up in a lot of client code that I see, that I end up looking at, though it's not, because most clients don't use SSH for authentication, it's not in that exact form. How it turns up is more like you'll have a user record with an admin flag on. And in the profile screen of, update profile screen, you will have that lack of whitelisting, and that will allow you to upgrade your account to that of an admin, which is really, really bad in that situation, because typically in these sort of small client applications, the admin flag means you're an admin of that application. So you have access to all of the users and all of like the data that the owners of that application use. So it's really, really bad when it's in code, and it's one that you want to look for. I thought in Rails 4, because we've got strong parameters, that, yay, I'm not going to have to worry about mass assignment anymore. And it's just going to be a problem that goes away. But it turns out that's not the case, right? Because what strong parameters gives you is this permit method, permit bang. And what that does is it completely bypasses, right, all whitelisting. You don't have to do any whitelisting at all if you have this method in there, if you call this method. And like my initial obvious response is, why would they put that in strong parameters? Like, what is the point of that? Like, because it's just going to give developers an opportunity to bypass whitelisting. And then I realized, actually, again, it's not the Rails core team's responsibility to make your code more secure. In this case, the problem was not that this method was available, because if this method wasn't available, then some clown would start a Ruby gem called weak parameters and then just add it in their code anyway, right? Somebody figured that out, right? The problem was that whoever wrote this code did not know about mass assignment vulnerabilities, right? That's the problem we want to fix. Fixing it in the code is not going to work, right? Fixing it by having like a static analysis tool might like flag this and help them accidentally, but it's not a scalable solution for future vulnerabilities. What we need is awareness amongst developers of problems like this so that they don't run into them by accident. The final sort of case study I'm going to talk about, or example of vulnerability, is a leaked session secret. And this one is absolutely devastating. The technical explanation for this is a little bit difficult, so you'll have to bear with me. I'll be honest, I haven't actually communicated the graveness of this vulnerability very well, either in a talk or in an email, but I'm going to give it a crack anyway, right? So to understand this, well, firstly, for security researchers, there's like different levels of vulnerability that they find, different levels of exploit. And the holy grail, like the one that they like yearn to get on every project they're on, is called remote code execution. That's when you, as an attacker, can make that application run any arbitrary code that you decide. Because once you've done that, it's a very, very small step from that to root on the box to installing a rootkit, which lies to you and like intercepts system calls and stuff like that, such that you have no idea that that box has been completely like owned, right? So they really want remote code executions. And this, the way leaking your session secret in a way that Rails handles sessions by default, is a gateway to that almost instantaneously, right? And that's why it's such a big deal. And here's how it works. To explain this, I'll have to explain how Rails handles sessions by default. Now, in your controllers for your Rails applications, you're given a method session, a hash sessions that you can add things to, and that jumps outside the request context. So the purpose of that is such that you want to put data in there that you can get back on subsequent requests for that same user, right? That's the purpose of having a session hash. Now, what happens under the covers by default in Rails is that everything you put in there, it takes that data, it encrypts it, it signs it using this session secret. So it encrypts it and signs it both using this session secret. It then puts that data into a set cookie header, which it sends down in the response to the client. Okay? The client is typically a web browser. The web browser gets that data in the set cookie header. It sends it back on subsequent requests, and it will, when it gets to the server, it's going to be verified using that signature, using the same secret. It's going to be decrypted using the same secret. And then whatever data was put in there was serialized on the way in, and it's deserialized on the way out, right, with Marshall dump and Marshall load. The data you've got in there is serialized Ruby objects. And what that means is when you run Marshall load, whatever objects were in that data, were in that serialized data, get initialized in your Rails process, right? The objects are created. It's as though you called class.new on whatever the objects they are, right? Now, this is okay if you can keep this session actually secret, right? But unsurprisingly, there are many, many ways that you can lose this secret, right? Because it's something in your code base. And I can go into enumerate the ways you can lose your secret to an attacker in questions, but that's a little bit longer than will fit into this explanation. But take it on faith from me that you can get hold of secrets in a variety of different ways, okay? Now, what an attacker can do when they have that secret is craft an arbitrary message, right? They can craft whatever objects they want in a way such that they can encrypt them and verify them in a way that your server then has to pass. Because if it didn't pass it, then your normal sessions wouldn't work, right? It does it in the exact same way. And it took a while to figure it out, but people have used this vulnerability to execute arbitrary code. So the minute you lose your session secret, which used to be in config initializers, secret token.rb, it's now in secrets.yaml. If you lose that, then that's it, game over. The advice I give to all of my clients is to just avoid all of this horribleness, right? Just avoid this drama by just keeping your sessions server-side, right? You can keep them in Redis. Redis is awesome. We had a great talk about Redis. Redis is great. Use that, right? Just put all of your sessions in there and sleep easy, right? That's all you need to do. And there's other security-related reasons why putting your session server-side is a good idea. I'm not going to go into them, but you can ask me in questions or ask me afterwards. But keeping your session server-side is one of the most important things I think you should be doing if you're running a Rails application in production. Okay. So those are the three case studies I wanted to talk to you about. A lack of access control, mass assignment, and a leaked session secret. Okay. So recommendations for you. This part is a little bit important. I know we've had a series of extremely good talks. And I'm exhausted, right, from watching them. Okay, they've just been really, really good. A lot, really, really intense. I'm just about able to stand up here and present this one right now. Okay, but I've traveled 10,000 kilometers to tell you the stuff I'm going to tell you in the next 30 seconds. So if you're bored of this talk, I just ask for these 30 seconds if I can have your attention, and then you can go back to what you were doing. I promise, right? I know you're waiting for the football because football's a big deal here, and there's some kind of championship thing going on. I don't get it, but I know it's important to you. But just for 30 seconds, I'd really like you to listen to what I have to say about this, because this one recommendation is really, really important. This is the absolute bare minimum, as in, if you do this, you will not be the lowest hanging fruit. This is what you must do if you run any web application in production, right? This is it. This is a 3-step process, and if you can do this, you are better than most teams at building secure software, and still, it's only the bare minimum, okay? Step 1, make a list of all software you use in production, right? That's your database, that's your web server, that's all the stuff you use, your libraries, your Rails version, your gem file, all of that stuff, okay? Do it yourself. Make a list of all of those things. Step 2, sign up for the security mailing list, or if they don't have a security mailing list, just a developer mailing list for that bit of software. And step 3, when a serious vulnerability is reported, you stop what you were doing that day. Everything else can wait, right? You stop. You assess the damage it has, the impact it has on your application, and you patch right now. Okay? Right this second. Your agile scrum band sprint planning meeting can wait. Okay? That doesn't need to happen. This needs to happen straight away. I'm going to repeat them. Step 1, make a list of all software and libraries that you are in production. Step 2, sign up to their security mailing list. And step 3, when a serious vulnerability is reported, you assess the impact and you patch immediately. Here's why. So the timeline for these sort of attacks works like this, right? A vulnerability is reported publicly, and people who are interested in this stuff, and there are people who are very interested in this stuff, are listening out for that. They are on these mailing lists, right? And they're thinking, right, when something comes out, the first thing I'm going to do is I'm going to create an exploit script, right? And all that script does is I pass it an IP address, and then it tries to see if this vulnerability works on a particular IP address, right? It's just fire and forget. They don't care, right? And what they do is they run that script on all the IP addresses on the internet, okay? So as you're sitting there, having your coffee in the morning and I don't know, debating, the benefits of, Demeter's Law, whatever it is that you software developers do, as that's happening, right, you're literally racing a for loop to get your application patched. And the reason I'm kind of adamant about this, and this is, fairly standard, advice from the security community, but I'm particularly adamant about this, is because a couple of years ago, you may know that there was, this massive YAML parsing Rails vulnerability. And I was, also the security guy back then, and I'd said to everybody in, kind of my local community that if you have some problems with Rails applications or security stuff and you just want to talk or have my advice or help you out with stuff, just send me an email. And somebody got in touch with me. And they said, oh, I heard about this like Rails vulnerability a couple of weeks ago. Should I patch this? And I said, well, really, by now you should just reimage the box, right? And he said, well, there's some stuff I want to, can you just have a look at my server to see if I've been hacked? I said, okay. And the stuff I found on there, like, as a parent, who'd just become a parent, it was absolutely heartbreaking. It was unacceptable that this basically the server was being used to distribute content that was just horrible and disgusting, and we had to get the police involved, and it had a really big effect on me, right? Like, it was not a pleasant experience, and it was at that point I realized that, like, playtime's over. Like, this is not a hobby anymore. It's time to take security seriously and, like, start talking to people about it and getting stuff fixed, right? So that's the reason why I'm really adamant about you doing at least this, because it's the bare minimum, okay? On to other recommendations. Spend some skill points on security. You're all here because you want to become better developers, I think, right? You've come to RubyConf Uruguay. You've paid money to come here. You've probably flown from somewhere else or taken like a long journey to get here. You're here to improve your skills, right? And there are a lot of things that you want to work on. There's different languages, there's different data stores, there's all sorts of different stuff that you want to experiment with. But I have a request that you spend a little bit of time working on your security skills as well. The kind of sales point for that, I guess, is that security is important no matter what language stack you use, right? You're going to, I think secure software is, by definition, better software. So, like, building secure software is going to be good for you no matter what technologies you use to build it. And you need dedicated time on security for that to happen. The best way to learn about security, in my opinion, is to actually implement exploits by hand, right? Look at an application and think about how you would trick it into doing things that it wasn't intended for you to do, right? And if you can't find relevant exercises that are to do with Rails and Ruby, I run a workshop like in London where I get 16 developers together and they work through a bunch of applications I've created for them. And because like you're all in RubyConf Uruguay and I love all of you, all you have to do to get those exercises is email me and I'll email them to access to you. Okay. So I'll have my email address at the end. So let me know if you want those and I will send them to you straight away. Okay. Secondly, after you've improved your security skills, keep track of vulnerabilities in your code. You already keep track of stuff about your system that's important to you, right? You have a bug tracker, you have a feature tracker, somewhere. I don't care how you do it. I'm not particular about tools, but like somewhere write down what you think are vulnerabilities, right? And if you're not confident about what is a vulnerability and what isn't, then just keep it in like a private markdown file, right? Just things that you think are just weird from a security perspective, and just so that you, at least on your own or as a team, have a place to talk about that stuff, right? Because what I think the biggest problem, like for me, is that developers don't talk about security very much, right? We've been here for 2 days. We talked about responsible code. We talked about not being evil. We talked about all that stuff. But only in passing did we once or twice even hint around security, which might be deliberate. Maybe they were waiting for my talk, but like it doesn't seem to be something that we have baked into our culture. So what I'd like is for you to keep track of the vulnerabilities in your code, and a couple of things will emerge from this. Firstly, if you do this for maybe 6 months to a year's time, a lot of things will build up that you think are just weird or perhaps a security problem. And at that stage, you'll start noticing ways to put them together in creative and interesting ways to break your application thoroughly, right? Secondly, if you have a place to talk about this stuff, it'll come to the forefront of what your team worries about, right? If I asked you a question, how much time as a team or as a developer do you spend thinking about the security of your application? Maybe you'll say something like, I don't know, 5 minutes a week, 10 minutes a week? How would you feel about putting that on your security page, right? On your page, saying our team only spends 10 minutes a week thinking about security, right? How do you think your users would feel about that, right? I don't think anybody would want to put that on that page, so maybe it might be an idea to do something about that, right? And finally, my last recommendation, and this one is really key for recovering from breaches. Make recovering from breaches easy, right? And there's nothing in this that isn't like obviously good DevOps practice, right? Make backups. Backups are a good thing. That's not particularly controversial advice, but one pointer you might want to focus on with that is make sure that you've practiced recovering from backups, right? Because, right, like so you do the backups and then make sure that at least once you've drilled the process of going from a backup to a data store up and running, accepting connections, and maybe you have some smoke tests around that. And how that process works. It doesn't need to be a quick process, especially if you've got a lot of data in your system. It's not going to be a quick process. But it needs to be a knowable process. You don't want to learn how to do that on patch day when you've been compromised and something terrible has happened and like lightning has struck your data center or whatever, right? The other one for this is another obvious good ops best practice. Make sure that you can build your entire infrastructure from scratch at will, okay? If your data center were to catch fire tomorrow, how long would it take for you to go from where you are at that point with absolutely nothing working to your system working again? Is that a 2-week process? Is that a 2-day process? Or is it a 20-minute process? And if it's a longer time scale, then how can you make it shorter, right? Preferably automated. Use whatever tools you want. Puppet, Chef, Ansible. I like Ansible right now, but if you want bash scripts or even a markdown file with a list of commands for like somebody to type into a terminal, good enough, as long as you have a knowable process that gets you from absolutely nothing to a working website up and running, okay? So, thank you very much for listening. To summarize my talk, there are 3 steps that you need to take, okay? That are the absolute bare minimum for keeping a website secure in production. Number 1, you will make a list of all the software that you're running in production. Number 2, you will sign up to all the security mailing lists. And number 3, for all of those mailing lists, when you get a notification of a serious vulnerability, you will assess the damage, you will assess the impact it has on your code, and you will patch immediately, okay? Thank you very much for having me. This is amazing. This is my first ever Ruby conference. You're all wonderful. The organizers are wonderful. The speakers are wonderful. And the translators are amazing, right? Have you been listening? Like, this is unbelievable, right? So thank you very much.